Good morning, my dear students. Today also we are going to continue with the numericals based on current electricity like we are done in the last class. Okay, we will be dealing with some numericals which is given in the book as an exercise for you in page number 202. We are doing from question number 21. Alright, so let's begin now. For question number 21, the question reads, a resistor of 6 ohm is connected in series with another resistance of 4 ohm. So, since the diagram is not given to you, you need to draw the diagram. Looking at the question, a resistor of 6 ohm is connected in series with another resistor of 4 ohm. Okay. A potential difference of 20 volt is applied across the combination. So, this entire combination, a potential difference of 20 volt is applied. You need to calculate the part 1, the current in the circuit, and in the second part you need to draw the potential difference across the 6 ohm resistor. Alright, so let's begin with the solution. First of all, let's complete the circuit diagram. This is the complete circuit diagram. Resistor 6 ohm, 4 ohm in series connected across a supply of 20 volt. Okay, now the first part is to calculate the current across the circuit. For current, you should first find out the total resistance of the circuit, which is nothing but resistance in series 6 plus 4, that is equal to 10 ohm. Okay, and the total resistance is this much, and the potential difference applied across this combination is 20 volt. Part 1 or part A, to calculate the total current, we are going to apply Ohm's law. From Ohm's law, you know V is equal to, mathematical form of Ohm's law is V is equal to IR. So, I will be equal to V divided by R, and this R is the total resistance of the combination. So, I am going to apply for current, I is equal to V by R. V from the question it is 20 and R we have calculated it to be 10 ohm. So, the current for this circuit flowing through this circuit is 2 ampere. So, this is the solution for part A. Let's go to the second part solution. You need to calculate the potential difference across the 6 ohm resistor. Now, one potential difference from the supply has been given to you. The question has asked you to calculate potential difference across this one. You should again know that, recall that the potential difference when it passes through the resistors in series, it gets divided according to the value of resistances. That's why across 6 ohm and 4 ohm the value of potential difference will be different. So, what will be the potential difference across 6 ohm? You will again apply Ohm's law. V is equal to IR. Since we have calculated this I in the previous question, so this is solution for part B. So, this is potential difference across the 4 ohm resistor. I was calculated to be 2, okay, and the resistance we are taking into consideration is only this 6 one. We are not taking that into consideration. So, instead of 6 plus 4, we are just taking 6 because the question has asked you to find the potential difference across the 6 ohm only. So, 2 into 6 is equal to 12 volt. So, this 20 volt, when it crosses this combination, this will be having a potential difference of 12 volt, and the remaining, if the question in case asks you to find out the potential difference across the 4 ohm, here the next part is very simple. It is 20, out of which 12 has gone here. That means potential difference across the 4 ohm will be 20 minus 12, that is equal to 8 volt. So, PD across this one is 12 volt and PD across this one is 8 volt. On adding, you will be getting 20 volt. Okay, let's proceed to the next question. Number 22. The question reads, 2 resistors of resistance 22, yes. 2 resistors of resistance 4 ohm and 6 ohm, same values, okay, are connected in parallel to a cell. to draw a current of 0.5 ampere from the cell. Now in this question, the two resistors are not in series, they are in parallel. Let's draw the circuit diagram first. The circuit diagram is, I will just draw it here. 4, 6 in parallel. So this is 4 ohm, this is 6 ohm. In parallel to a supply to a current supply, the value of which is not given, and the current flowing through this circuit is 0.5 ampere. So this is question number 22. Okay, let's find the solution. Part A. For part A, draw a label diagram for the arrangement. Done. Okay. Second part, calculate the current in each resistor. To find out the current in each resistor, you should first find out the parallel combination of the two resistors. Okay, Rp is equal to 4 plus 6 by 4 into 6. This is the direct formula. If you have got two resistors, 10, 6 4s are 24. Okay, and it is equal to 12 by 5 ohm. Okay, so this is the parallel combination. The current for this entire circuit is 0.5 ampere. With the help of this parallel value and this current value, we can find out the voltage supply, that is the value of V here. Using the formula, V is equal to IR. So V is equal to I is 0.5 and R is 12 by 5. On solving, you will get 1.2 volt. So EMF of the cell, that is from the supply, the value of V is 1.2 volt. Now you need to calculate the current in each resistor. That means, you know, this 0.5 will not be flowing to both this, it will be divided, and some part of the current will be flowing through the 4 ohm and some part of the current will be flowing through the 6 ohm resistor. In parallel, current gets divided, isn't it? So current through 4 ohm resistor is, I'll just write it as I4, I across 4 is equal to V divided by R. Okay, the value of V is 1.2 and the value of R for us is 4. 1.2 divided by 4 is 0.3 ampere. This is how you find out the current if the resistors are in parallel. Now current through the 6 ohm resistor using the same formula, 1.2 V by R, R is 6 in this case, 1.2 divided by 6 will be equal to 0.2 ampere. This is how you find out the current flowing through each resistor if the resistors are connected in parallel. Okay, so first you will find the equivalent resistance, current. If this is not given, with the help of the total current and the equivalent resistance, you will be finding out the EMF. Okay, and in each part this EMF will be divided by the required resistor, then you will be finding out the current flowing through each resistor. Let's proceed to question number 24. We are not doing 23 as it is the same as question number 22. You can try it on your own. Now question 24, it reads, in the figure, now the figure is given to you, calculate the total resistance of the circuit. Let me draw the diagram first. Voltmeter, The reading shown by the voltmeter is 4 volt. A battery is connected. Ammeter which shows the current reading. The value of current in the circuit is 0.4 ampere. Then you have two resistors, one of 20 ohm and the other one unknown to us. Say the value of resistor here is R. Okay, resistance here is R. Now, the question reads, calculate the total resistance of the circuit. So, part A, total resistance of the circuit. We will come to that later because we do not know the value of R. Okay, so before beginning, we will find out the potential difference across the cell, that is value of V. It is just given in the question. It is equal to 4 volt. Okay, then current, as I told you, the reading shown by the ammeter 0.4 ampere. Okay, now with the help of the formula V is equal to IR. Now this R means the total resistance of the circuit. So it is R equivalent for the circuit. Okay, we will just rewrite the formula keeping R as the subject. R is equal to V by I. The value of V is 4 and the value of I is 0.4. On calculation, the total resistance of the circuit comes out to be 10 ohm, and this 10 ohm is a result of the combination of 20 ohm and this value of R. Okay, so this is how you find out the total resistance, by not using the combination formula but by using Ohm's law, that is V is equal to Ri. Next, moving to the second part, for the value of R. Okay, we can use now the formula 1 by R in parallel is equal to, or 1 by R equivalent is equal to 1 by R1, that is equal to 20 plus 1 by R. Okay, now this R equivalent was calculated in part 1 to be equal to 10 is equal to 1 by 20 plus 1 by R. On solving, the value of R comes to be 20 ohm. So the unknown value of R is equal to 20 ohm, which we have calculated using the parallel combination formula. Okay, and thirdly, you need to calculate the current flowing through R. In the similar manner like we have done in question number 22, we will find out the current flowing through R. Now R, we have calculated it to be 20 ohm. Okay, using the formula I is equal to V divided by R, as V is equal to IR from Ohm's law. Okay, V, it is the potential difference from the cell, because it is shown by the voltmeter, they will be having the same potential difference, 4 divided by R here is 20. So current flowing through this R is equal to 4 by 20, that is equal to 0.2 ampere. Okay, this is the solution to part C. Next, we will move on to the next question, question number 26. The question reads, a cell supplies a current of 0.2 ampere through two resistors, each of 2 ohm connected in parallel. Now you have got two resistors connected in parallel and the supply of current is equal to 1.2 ampere through the circuit. Okay, so you have got two cells in parallel, each of value is equal to 2 ohm, this also is equal to 2 ohm. And this is connected to a battery or a cell. Okay, Now the current for this one is 1.2 ampere. Okay. Now this is the circuit diagram for this given question. The question is actually, when the resistors are connected in series, it supplies a current of 0.4 ampere. It means that because this connection is in parallel, the amount of current will be different, that is 1.2 ampere. If you connect these two in series, the amount of current will be reduced to 0.4 ampere. The two situations are given to you. Okay, calculate the first part, internal resistance, and second part, EMF of the cell. Now, first, let us find out the value of Rp. Okay, Rp is equal to 2 into 2 divided by 2 plus 2. This is direct formula. 4 by 4 is equal to 1 ohm. So, Rp is equal to 1 ohm. Now, EMF of the cell is given by I into the total external resistance plus internal resistance of the cell. Okay, then replacing the value, EMF is equal to I is, the value of I is 1.2 into Rp is just 1 plus internal resistance is R. This is equation number 1. That's why two situations are given to you so that you can find two unknowns. One is this and the other one is R. Okay. Now for finding two values, you should frame one more equations using the second situation. Okay. From the second situation, that is in series. This is in parallel. Okay. In series, Rs is equal to 2 plus 2, that is equal to 4 ohm. Okay, that's why the current reduces. Now the value of resistance has increased, naturally the current's value will decrease. Now using the same formula, because the EMF and internal resistance of the cell will be the same no matter you connect it to in series or you connect it in parallel. Okay, EMF is equal to current I. Now if it is connected in series, the value of I reduces to 0.4, right? So instead of 1.2 in the previous one, here you will write 0.4. Value of Rs is 4 plus internal resistance R. This is equation number 2. Now we have got equation 1 and equation 2, and we have got two simultaneous equations, this and this. On solving them simultaneously, we will get the value of EMF as equal to, the value of EMF will be equal to 1.8 volt. This is the answer to part 2. Okay, and on solving these two equations simultaneously, you can go for substitution method, elimination method, your choice. R will be equal to 0.5 ohm. This is the answer to part 1. So this is how you are going to find out the value of EMF of the cell and internal resistance. If two situations are given, you need to frame two equations and you are going to solve it. Okay, let's do the last numerical for today's class. Question number 28 in your book. In the circuit diagram, 3 resistors are connected to a battery of EMF 2 volt and internal resistance 3 ohms. So the diagram is given like this to you. Okay, and 4 is in series with this combination and the supply is here. If you see 3 ohm here without any resistance symbol here, it means it is the internal resistance of the cell. Okay, and this is 2 volt, 2 ohm, and another unknown resistance of value R is given, and 4 ohm is in series with them. the supply for which is 0.25 ampere. So the current here is 0.25 ampere. Okay. First part of the question is to calculate the potential difference across the 4 ohm resistor. The potential difference across the 4 ohm resistor. So I is 0.25 ampere. Then equivalent resistance, that means total resistance for all these components taken together is, okay, first find out the potential difference across the 4 ohm. So PD across the 4 ohm resistor. To find out, you will apply V is equal to I into R. Okay, replace the values, 0.25 into the value of R, since it is across the 4 ohm resistor, it is in series, so 0.25 into 4 is equal to 1 volt. This is your answer to part 1. Part 2 or part B, the question reads, to find the potential difference across the internal resistance of the cell. That means, like we had found out the potential difference across the 4 ohm, we also need to find the potential difference across the internal resistance of the cell, that is across 3 ohm. Again applying V is equal to IR. Okay, so this is across the 3 ohm resistor. I is equal to 0.25 into R is equal to the value of internal resistance is equal to 3, that is equal to 0.75 volt. So this is the solution to part B. Let's quickly move to the third part, C. The question reads, the potential difference across R ohm or 2 ohm resistor. That means potential difference across this or this, it will be the same. That's why the question has asked you to find across this or this, it will be the same. To do so, the total supply, the EMF of the supply was 2. Okay, so it is PD across 2 ohm or R ohm. Okay, it will be the same. The total supply was 2 volt, out of which 0.75 and 1 are the potential differences across this and this. Okay, so the remaining will be naturally the potential difference across the 2 resistors in parallel. So it is 2 minus 0.75 plus 1 is 1.75, so it is equal to 0.25 volt. Okay, and lastly, the value of unknown resistance R, the value of R. For that, let's first find out the expression for this one. Rp is equal to 2 times R by 2 plus R. Since R is not known to us, we will leave it. Okay, then we have the total resistance in series as this Rp's value 2R by 2 plus R, plus we have 4 in series, plus we have 3, so 4 plus 3 is 7. So the total value of resistance for this entire circuit is equal to 7. Alright, now we are going to apply Ohm's law for this entire circuit. V is equal to I into the total resistance Rs. Okay, the value of V from the supply is 2. I is equal to 0.25. Okay, into Rs the value can be copied from the previous step, 2R by 2 plus R plus 7. Okay, now we have got one equation in which the value of R is unknown to us. On calculation, by solving it, the equation, the value of R comes to be 2 ohm. So this is how you are going to find the value of unknown resistance by applying Ohm's law. Okay, so that is all regarding the numericals. Every type of question that has been asked in ICSE and may be asked has been covered with this. Thank you.